So, hello everyone. I'm Sai Venkatakrishnan, PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So, welcome to the course on software security. So, this course is hosted on the platform provided by ISSS, which is Institute of Smart Structures and Systems, and also this is done in collaboration with CHERD um, Association, which is Center for Hardware Security and Security Entrepreneurship Research and Development. So this CHERD is basically a um, R&D organization plus a security awareness organization, which is funded by the Ministry of Electronics and Technology, Central Government Ministry, MeitY, and it is supported by both IIT Madras as well as IIT Kharagpur. So this was not initially planned, but if things fall in place, at the end of the course, once you complete your assignments and once you complete the course, you will be getting a certificate which is recognized by both CHERD as well as IEEE, right? So this today's session would be just a introductory session. So we'll get to know about each other. We'll get to know what you can expect from the course, and and the course logistics, and just a sneak peek into how the course contents would be, right? Um, so let's get started. And all the lectures would be recorded, and I'll be uploading it by the end of day, or by the end of day on the platform. So the link to the recordings, I'll be sharing it shortly. So, who am I? As I mentioned, I am a PhD scholar at IIT Madras. So, this is my website link. You can find more about me at this website. My area of research at IIT Madras is mainly with respect to system security, especially on the software security side, and a bit leaning towards the hardware also, as well as working on binaries and programming language security. So this is my area of research. So about you, I so as far as this course is concerned, I received over 300 registrations, but eventually around like 120 or half of them have joined the Discord server, right? And many of them, most of the students are from either from Belagapudi Ramakrishna Engineering College, Guru Nanak College, or IIT Madras or Anna University. Right? So let me just have a quick poll, and you can say which college institute you are from. Right? So I've launched a poll. You can just open your Google Meet window, and there will be, yeah, the poll. So let's just let me just wait for a minute and see the results. Okay. Um, Let me end the poll. We have received around 25 votes. It's good enough. So interesting. So we, as I mentioned, all the colleges, right? Velagapudi, Ramakrishna College, Guru Nanak, IIT Madras, they said good. So someone has specified others. So which specific college you're from? Um, can you just respond in the chat box? The student who mentioned specified the option others. Okay, Guru Nanak College. Okay, it's there actually. Okay, cool. So I had gone through the background survey that a few of you have submitted, and it's quite evident that most of you are from the computer background and have a bit of knowledge on the basics of computer architecture, the organization, as well as the C programming language and assembly language. Right? So let's just have a brief look at the course logistics. Right? So we'll be having two classes per week. So one is would be on Fridays and Saturdays, and as part of our course, we'll be having around three assignments. So this is sort of like three assignments as for now we have fixed based on your suggestion. If you want more assignments or something, it is flexible. So all these are flexible, right? So the number of assignments are flexible. Mostly around 2 to 3 assignments we'll be having based on how your time schedule is there and all those stuff. And but for sure we'll be having two quizzes. Okay, so the quiz would be sort of Google form based, short answer type questions, and it will hardly take around 50 minutes to answer. And also all the assignments and quizzes would be team based. So 4 to 5 members per team, and I have also shared team formation the forms. So I suggest everyone fill out those forms. Finally, when the assignments and quizzes have to be evaluated, I will evaluate only those submissions which are submitted as part of the team. If you are submitting individually, I won't be evaluating it. So kindly, if you don't have a team or something, please sync up among yourself in the team formation channel and try to form a team. So the reason why so usually these assignments in a normal course would be like two per team, but since I don't have any TAs to help me out, I should be correcting all your assignments and quizzes, right? So for based on that, due to that restriction, I have this constraint that 4 to 5 members per team. So please bear with me. So both the quizzes, the exams, as well as the assignments, everything is team based. You should just submit a single assignment or just submit once per team. That's enough. So the course agenda would be as follows. I assume everyone would have gone through the syllabus which was present as part of the flyer, right? So let me just have a quick a brief run through the course agenda, what we would be covering, right? So in week one, we would be covering the basics of program and the process. So basically, what I would be covering is how the process is getting loaded, process loading into an operating system, the internals, as well as how your program would be compiled down to a binary, and what's the binary format. So all these So all these I will be discussing as part of week 1, and also the program and the process layout. So all these I will be discussing as part of week 1, right? And as part of week 2, this will be a sort of a hands-on session where we will be using GDB mostly to inspect the process layout, as in the stack, and then your heap, where is it located, and common GDB commands that you would be using throughout the rest of your course. So week 2 and week 1 is sort of the background, uh, the uh, the base on which we would be discussing all these exploits and mitigations, right? So and also week 2 I'll be just having a small assembly refresher. So this assembly refresher wouldn't be in depth, so I assume most of you have quite a bit of knowledge on x86 assembly, just normal add, subtract, multiplication, load and store instructions. That would be good enough, right? So and any other new instructions in the x86 assembly that we would be coming across, we can as and when it comes across, we can easily sync up to it and learn about it. That's not an issue. So this would be the portions that we will be covering as part of week 2, and starting from week 3 we'll be delving into the actual aspects of this course, that is software security. So one aspect of this course is the course name. One I suggest should could have been named better, but the one thing is when you consider software, right, there are multiple software components that you are using in this real world applications. So for example, you have your database application where you're coding everything in SQL query language. Then you have your browsers which are mainly coded in JavaScript, HTML, the web technologies. And then you have your normal applications, for example your mobile applications, which are coded in Java, or these languages that support Android platform, and Swift for Apple in that sense. And then you have your normal device drivers and all those stuff, which are mainly coded in C and C++, right? So this part of the course will mainly focus on the vulnerabilities found in C and C++ code bases. So all the exploits and the mitigations that we will be coming across, that we'll be studying, are mainly associated, are present in C and C++ code bases, which are by default insecure, and that will be the main focus of this course. We won't be delving into exploits related to SQL or the web technologies. So we'll be covering those in a future iteration of this course. But one thing to be clear is, even though C and C++ is quite a bit popular language, and still actively being used in many real world applications, and all these exploits that we would be discussing holds good in also these JavaScript, Python, and any other language, right? These exploits that we would be discussing uh, will hold true in those languages also. But the only difference is the actual implementation of that exploit. The actual exploit will slightly vary, but the general idea of say a buffer overflow exploit or anything, a heap exploit, those will remain the same irrespective of the programming language that you code in, right? So here we would be taking C and C++ as the language of choice, because it's sort of the most insecure, as well as most of these exploits started where usually found in those languages, and then they were researched on pretty well, right? So this the tentative agenda of this course. So from week 3 to week 9, we would be discussing all these different exploits. So week 6 is sort of like a mitigation, as in for all the previous exploits, any specific mitigations are there, so that we will be discussing. And again, we'll be jumping back to exploits, right? And throughout all these, from week 3 to week 9, everything would be sort of practical. So the Friday sessions would be theoretical mostly. I'll be first explaining the theory behind those exploits, and the Saturday session would be a hands-on session where we'll be uh, sharing our terminal and looking into the internals of the program and process, and take an example and work through the example and find out how an exploit is found, and how we can uh, how it is made, how that vulnerability is exploited by the attacker. So the Saturday sessions would mostly be the practical sessions, the hands-on sessions. Okay, so this is the tentative schedule. Based on the time availability and as well as your interest, we can extend for a week or a couple of weeks also this course. We can add advanced security exploits also, but that option is left to you. If you are interested, we can extend this course up to a couple of weeks. I'm open with that. So later during the end of the course, around like week 9 or something, I'll be sending out a form where you can express your interest, whether you want an extra continuation of this course for a week or 2 weeks, right? So that's the course agenda, and as specified on the Discord channel, all our communication will be on Discord, and um, do form your teams before I release the first assignment. Probably next in a couple of weeks, I'll be releasing the first assignment, and the assignment deadlines are not very tight. It is relaxed, so that's not an issue. And another thing which I want to mention is I assume your semester exams and your college would be coming in the month of November or something. We'll try to wrap up the sessions by then. But if not, what we can do is for a week or two in the month of November, we can have a small break and then resume the sessions once the exams are over, right? So we can have that sort of a schedule if you have if you are caught up in the in your college exams, and if you have to prepare, right? Right. And that's one. And the other aspect is and I assume everyone have installed the Kali Linux virtual machine. Right, so all exercises and everything I would be demonstrating in that mission. Right? And usually I'll try to make sure so a couple of exploits. For example, the heap exploits require a specific version of the uh, C library and all that. Some dependencies are there which is sort which should be installed. So for those, the having it on a virtual machine would be pretty easy to reproduce the exploit and better understand it. So let's have a sneak peek into the course. So today I will be delving into the actual. I will be looking into the process loading part, but we'll just have a quick, a brief intro into how the course would look like, and what the a process layout would be, right? So let me share my terminal. Let me share a code snippet. So till now, do you have any queries or anything with respect to the course agenda? And yeah, the other point I forgot to mention is all the lectures should be recorded, and attendance is not compulsory, but I suggest you attend the courses. If you have any queries, you can either post it in the Discord forum. So I'll be creating a channel for each week. You can post that corresponding week's queries in that specific channel so that it will be better organized. Attendance is not compulsory, but if you want to get a certificate at the end of the course, you should submit all your assignments, and as well as all you should attend all the quizzes, both the quizzes you should attend. The quizzes, the pass mark could be pretty low only. It's not an issue. Yeah, it will be set easy, so that's not a issue. And also you will be given ample time to submit your assignments. So there is not a specific pass mark or anything, but I hope you all perform well in the assignments as well as quizzes. Okay, so the goal of this course is to get you introduced to these security exploits and mitigations, and uh, uh, so that you can further pick a specific direction in this cyber security field and continue in that direction, right? So any doubts till now? You have any queries, specific queries you have? So if you have any queries, you can pass a message in the chat box, or you can unmute yourself and speak. So let me share a small snippet of code. Okay, so Vasam Praveen has asked a question. Will this course improve my ethical hacking skills? So Vasam, what's your current background on ethical hacking and all that stuff? So okay, so ethical hacking course, if I'm correct, uh, it is it is usually delving on the web technologies, and it will be sort of a high level overview on the exploits. Um I'm not sure. Okay, so this as part of this course is concerned, right? The the exploits and all these mitigations that you learn, you can very well use it in so CTF is sort of similar to these. Okay, so CTF is sort of capture the flag events. So basically, these are security hackathons where given a program, a binary, you should basically find exploits, right? And the CTFs are pretty common and are pretty well known in cyber security field. And all these concepts, buffer overflow exploits, ROP and heap exploits, are sort of the stepping stone to get introduced into these capture the flag competitions. And this is part of the ethical hacking content actually. So getting to know these exploits will definitely improve your ethical hacking skills. And as part of the course also, we'll be looking at a couple of CTF platform, and we'll be taking a couple of examples from that platform, and we'll be using tools which will help us in writing out proper exploits. So regarding that, the details I'll introduce the tools as and uh, during the rest of the course I'll introduce it. Bug bounties. So Right, so this class of binary exploits will work in the real world. So, so the hands-on practical sessions that I will be conducting will have a binary where the exploit is known already, right? But in your real-world solution, you basically have like two parts. So one, you should find which particular exploit you're looking for, and then once that exploit is found, you should try to make it make that vulnerability actually exploitable and misuse that and gain control. So um, yes, so these exploits are found in the real world and are still pretty active. So if you notice um, the list of common vulnerabilities enumeration like CVEs and all those stuff which are released recently, even in 2022 and 23, many of the vulnerabilities that are uh, introduced that are found in real world applications are pertaining to these memory or memory based errors like buffer overflow and all those stuff. So regarding Verb Suite and the tools that are available in Kali, we will have um discussion about it later during the course, right? So we'll go step by step in the course. First, we'll understand the process logics, GDB, and all that stuff, because having a good base is definitely important, specifically in a security course, because uh, you should know the basics. The basics should be strong enough. Then only you will be able to find out vulnerabilities in a real world scenario when you in this bug bounty programs and all that stuff. Your basics should be strong enough. You should be a step ahead of the developer in terms of uh, the technology knowledge and all that stuff if you want to successfully find an exploit in a program logic in the real world scenario, right? So let me share my screen and share a snippet of code. So is my screen visible? Okay, so okay, so we have a small program, and it has a main function. The main function does nothing. So let me just execute this program and show. So I first compiled the program source1.c, okay, and then I execute it. So basically it asks for my username, and I should enter an OTP, a one-time password. Let me I don't know the OTP, so let me just enter 234, okay, and it tells my actual OTP is something else, some unprintable characters, Unicode characters, whereas I have provided 234. Just a second. Okay, so I have provided 234, but the actual OTP was something else, and it shows the error message, try again, and it prints done. Okay, so this is the logic of the program. So it reads my username, it reads my OTP, and compares it with the actual OTP. And if it's not equal, it generates this error message and it exits. And this is the logic of the program. So it starts from the main function, it invokes the process function. So all this logic entering the username until here is part of the process function, and once it returns, it prints this done message. So now let's have a look at what this process function is. Okay, so this is the process function over here. Okay, so I'll just give a couple of minutes time. Um, can anyone uh, find out my what this program does, and what's the actual OTP that I should enter for the program to pass successfully. So if you notice this line number 33, it basically compares. So I have three variables. One is the input OTP, which reads the input from the user. I use this getters function, and then I have the actual OTP, right? And then I get my username in this variable, and I compare my input OTP with the actual OTP, and if both are equal, I invoke this function reveal secret, which prints a congrats message. Else it prints this try again message. So I'll give you a couple of minutes time, go through this process function and tell me what the actual OTP is, and what the input OTP should be for this reveal secret function to be invoked. Basically my comparison should succeed, and the try again message should not be displayed. So I'll give you a couple of minutes, like 3 minutes also. Go through this program logic and key in your answers in the chat message. Anyone else wants to try? Uh, Anyone else wants to key in any answers that you know, like what the actual OTP should be? Any guesses? So some of them have mentioned it. Okay, so let us so basically before delving into the explanation of the program, one student Farouk has asked to explain the commands. So we'll be basically using this Kali Linux or Linux variant to compile and showcase these exploits. So I'm using the GCC compiler, which is a C compiler, to compile C code base. And so once I compile that, I usually you will get a binary which will be named a.out. So this sort of, it can be named anything by passing a command line argument. Okay, and so for example, I can just name it differently also. So I get a binary named psi, and if I execute it, it does the same. And if you notice the file type of this binary, whatever is getting emitted by the compiler, it's you have this type called ELF 64-bit and x86 64 version dynamically linked. So in the later part of this course, in the second week and in the first week in the next lecture, we'll be looking at what this ELF format is for a binary and what each term means in this output, in this display message, right? What we mean by the ELF format, what it means by 64-bit LSB, and what it means by dynamically linked, the interpreter, and not script, and all these messages we will be looking at individually and understanding what a binary will actually represent, what does it look like internally. Okay, so coming back to the program logic, right? uh, so most of you have guessed it correctly. So let me explain the program logic. We declare three variables. One is the input OTP that I read, that the user inputs. The other is the actual OTP, just the OTP, and the name, the username. So the name is insignificant in here. So it just reads the username and displays it. Okay, and here if you notice, this part of the logic, so from lines 16 to 19, this is where I am actually populating my actual OTP. Okay, so over here this specific line, I am opening a file descriptor pointing to this file slash dev u random. So this u random is nothing but it's a device file present in Linux systems, and it's sort of a pseudo random number generator. Okay, so each time I read from a file, a normal file operation in C, you'll be using this read and write calls, right? Read to a file and write to a file. Similarly, I'll opening a file handler, a file descriptor, specifying this the name of the file as slash dev slash urandom. So this by default present in Linux systems, and this when you read from this file, each time you read from the file, it will be a different uh, number. Right? It will be randomly generated, and and what I do is I open this file descriptor, I open the handle to this file, and I read just three characters from this random file into my OTP character array, and I close the file connection. So basically, the actual OTP, I am not hard coding it to a specific character, some specific value. I am not associating it. Instead, I am randomly initializing it at runtime via this urandom field. Okay, uh, urandom file. And once I'm initializing my actual OTP with some random value, I get the username, and I require the user to input the OTP uh, uh, content, the OTP value, and then I display the OTP, what my actual OTP is, and then the input OTP, and if both are equal, I invoke this reveal secret function. Else I just exit from the program displaying the error message. Okay, so in this logic, right, my goal is to can anyone tell me, is it so in this thing, is it possible for me to provide the correct OTP? Is it possible for me? Right. So, right. If we open the file, we can find, assuming the attacker does not have access to the file, right? We can we can remove that we can have that assumption. So we can have look at the logs, but assume the attacker does not have direct access to the system. So assume that he's accessing over a network, and he just has this display message on a screen, on the attacker screen, right? So basically I just have this interface which is just looping till I get the correct OTP, right? So I just enter my username and it just keeps on repeating. So I enter, it's wrong again. So again I enter something, say 111, it's wrong. So if you notice, my actual OTP keeps on changing and it's randomized. Yes, the three digit pin should still be doable using brute force, but say if it's I increase the number of digits, say if it's like 32 bits or something, then what is the, if it's 64 bits, right? So that's the issue. So in that case, there is no way my actual OTP, I can provide an OTP to the program, uh, uh, provide I can provide the actual OTP correctly, so that I can print the congrats message, I can invoke this reveal secret. That's not possible at all, right? But there is a way where I can find out the actual OTP without gaining access to my the urandom file, or looking at any logs. Just by changing the input, right, I can gain access to this reveal secret function. So can anyone guess how it can be done? So I should not change the program logic, the program source code. We should not be changing that. Just by changing the input that I provide to this input OTP, I'm telling that there is a way for me to pass this condition, string compare condition, and invoke the reveal secret function. So can anyone have any guesses? It is an exploit, yes. It is something to do with a memory exploit. Any guesses? No, so some of you are telling to change the program logic and all that stuff. What I'm telling is we need not touch the program source code at all, right? We need not change this equal to 0 in line 32 to something else, or change the logic and all that stuff. We need not do anything. Just we should change the exploit, the input, sorry. Okay, so the basic assumption that most of the developers are having, right? So whenever you are asked to code some application, what you assume is whoever is using your application is sort of a good person and will adhere to all the assumptions or the rules that you had in your mind. For example, over here I have this message telling that we can have just three characters. We should maximum three characters should only be present in your OTP. So the developer who is coding this program usually assumes that whoever is using this code will follow these rules blindly and just input three characters alone. But in a real world scenario, uh, it's this is not the case. There are attackers who will always be trying to break your program in every possible way, and instead of giving just three characters, let's just try to give four characters and see what happens. Okay, it does nothing, it just returns back. Okay, so one small thing to notice over here is the previous case when I gave just three characters. If you notice, my actual OTP was initialized to something, but if you notice over here, if I provide four characters or something, it's sort of different, right? My actual OTP is blank. It's not it's not initialized to some random value. So what we can just do is, let me just increase my OTP size, as in the input whatever I'm giving, right? Instead of following the rule that only three characters should be provided, let me give five or six characters. Okay. Right. So if you notice over here, I gave my input OTP as this huge number, triple two triple two, and my input OTP is initialized with this specific number triple two, and the remaining three twos, right, which I gave extra as part of the input OTP. Out of that, only two digits were passed to this actual OTP. So basically, my actual OTP. So basically, what I can do is I can print my actual OTP over here. So this just for okay. So if you notice over here, initially my actual OTP is some random value after reading the random file, but now after entering this huge number, six twos, right? The actual OTP which was displayed is not the one which it was initialized to. So these two values are sort of different. Okay, and if I just extend the number of digits, right, which is being passed to input OTP, I basically change my actual OTP and I get to this reveals secret function. Right. So basically what is happening behind the scene is, for this to better understand what's happening, we should understand how my process layout is. Okay. So let me share my screen. So basically, when you have a process loaded into memory, right? So for if you have a process, so assuming this, you every process gets loaded into memory, and the starting address, so it's loaded into your main memory, and it is provided some address, right? For example, let's just assume 0x1000, okay, and then it's till some 0x 4000 or something, okay. So basically, the first part of your process would be your code segment. The code segment is basically all your instructions, all the functions, your instructions, everything, your main function and everything would be part of your code segment, right? And the next segment in your process would be your um, data segment. So by data segment, what it means is, say if you have any global variables which are initialized. For say for example, you have a function in main, some logic, and outside the main function, you initialize a global value, say in a equal to 5, or you initialize an array, say in b of 10 equal to 111, something like this, right? So all these global variables having some specific value initialized to some value statically in the program logic itself, all those would be stored as part of a segment called as the data segment. And followed by that, you have a segment called as the BSS segment. So the BSS segment is nothing but not all global variables in your logic would be having initialized to some value. So I can have just a global variable like in C, and I won't initialize it to some specific value, right? I can have another global variable like int D or character D, like that, and there is no specific value to initialize those variables with. In that case, what I do is the OS automatically initializes all these uninitialized variables, these uninitialized global variables, to 0, okay, and all these variables, right, these uninitialized global variables are stored as part of this segment called as BSS, okay, and followed by the BSS is your heap region. So this heap region does, so all these segments till now, whatever we have seen, the code segment, the data segment and the BSS segment, is sort of statically determined, the size of these segments. So what I mean by statically determined is, when you compile your application, right, all your global variables, the size of your functions, so these many instructions are present in the main function, these many instructions are present in the process function, so all those are sort of determined at the compilation itself. So you cannot change those when you are executing your program, and also your global variables and all that stuff is sort of determined at compile time. So what it means is, the size of these segments, so finally when you have all these when you have a look at your a.out file or the executable, right, the internals that you'll be looking into later, uh, the binary file will be having this code segment, data segment, and this BSS segment also, right? And when we execute this, when we execute this binary, right, it gets loaded into the operating system, and you start a process. And what happens is it kinds of starts out this heap and as well as your stack to the process. So this basically your process layout. This whole diagram, this is the process layout. So you will be having your code segment, data segment and BSS, which are statically determined, and you have your heap and stack also. So basically by heap, what you mean, what contents would be there is any memory you allocate using malloc or calloc, right? Or using this new function in C++. So any of these dynamic memory allocations that you would be using would all be allocated as part of this heap region, and this heap region size is not fixed. So that's why I've added this symbol, which means it grows downwards. Okay, so as and when, say for example, initially it will be assigned around 100 KB, and once I've used up the 100 KB of size, I'm allocating different sized objects right on the heap, and if I require more size, I should request my operating system and it will increase my heap size to say 200 KB, something like that. Okay, so this is your heap. Now coming to stack. Stack is the important aspect of the process. So the stack contains all your local variables and also the call context. So regarding this, we'll discuss later. Okay, but we'll focus on this aspect. Contains all the local variables. Okay, so when you have a look at the for example, taking this example of the process function that we looked at, right? We had three variables defined within the process function, which is char, um, input OTP, character OTP, and character name. Okay, so these are the three variables that that we are defining as part of the the process function, right? And all these variables would be allocated in the stack region. Okay, so and the order in which they will be allocated is in this in this decreasing address range, in this order. So basically my my first my first variable input OTP would be uh, so assuming this the way my stack looks. So basically what happens is my stack sort of grows upwards, as in starting from a higher address, it, it grows in this direction. Okay, So what happens is the order in which, okay, so every function which is active and which I'm actively executing, so every function that I'm currently executing in will have an associated stack frame. So basically what I mean is, when I initially invoke the main function, there will be a stack frame associated with it, stack frame 1, okay, and this stack frame 1 would contain all my local variables within the main function. All those local variables would be allocated within this stack frame 1. And now when main calls the process function, okay, I will allocate a new stack frame, which is stack frame 2, and all the local variables as part of the process function would be allocated in this stack frame 2. And how these should be allocated, in which order these stack frames should be allocated, is in this decreasing order. So my stack frame 1, so if currently if my main function is executing, my stack frame 1 would be present over here, and when I invoke the process function, I'll be allocating stack frame 2 on top of stack frame 1, basically at a lower address. And when process function calls some other function, I'll be allocating over here a new stack frame. Okay, so this is a high level overview of stack frame, and local variables pertaining to a function are stored in these stack frames. Now if we have a closer look at how the variables are stored within each stack frame. So here in the process function, when I execute, I'm having three local variables, which is the input OTP, the OTP, and name. Right? So these three variables would be stored in this particular sequence. So this my stack frame 2 means this is the order in which my variables would be stored. And basically what happens is, when I'm reading when I want to read the input from the user, so basically my pointer to the character array will start from this region. Say if I'm reading the name, the username, my pointer would start. So if you notice, we'll be using the fgetters function to read the name from the user. So I'll be using fgetters name from the standard input and around 10 characters, right? So what it will do is, it will start reading from this specific position, from the start of this name character array, and it will populate the 10 characters in this name array, the username, right? And now when I want to populate the OTP array, the actual OTP array, it will open the file, the urandom file, right? And it will populate the OTP using the fread command, or the read function. And when I'm using this input OTP, when I want to read this input OTP from the user, I'm using the function getters, okay, and this getters function is sort of vulnerable. We'll look into why it's vulnerable, right? And when it reads from the user using this getters function, I basically am populating in this um, um, in this manner. So basically so my first variable would be present over here, 2, 3 and 4. So if I'm giving this number 2, 3, 4, this is the order in which it is keyed in. So this is the zeroth index over here, followed by the first index and then the second index. So basically 3 elements as part of your input OTP. Now the issue with the getters function is, if you notice over here, so let me share the code snippet. So if you notice over here, I'm using this function called getS specifically to read my input OTP, whereas I'm using this function called fgetS to read my username. So what's the difference between fgetS and getS is that in fgetS I'm specifying the number of characters at max I should read from the user. So for example, over here if I'm declaring the character array name to be of just 10 characters, then I'm providing the size of this array to fgetS, so that if the user keys in uh, more than 10 characters, it basically stops accepting the inputs from the user and just continues with the execution, right? So that's what this parameter fgetS, passing the size of name parameter to fgetS is all about. So basically it prevents the user from keying in more number of characters than expected. Whereas if you notice the function input function that I am using to enter the input OTP, I am not using fgetS, instead I am using a normal getS function. And if you notice in this getS function, I am just passing the address, I'm just passing this array variable input underscore OTP, specifically means at starting from this location, say input OTP is at 0x 2000, right? So starting from 0x2000, whatever value my user inputs, I should write it on to my stack location starting from 0x2000. So once I start uh, uh, providing the input 2, 3, 4, some numbers, right? It will keep on be returned as part of the stack starting from this 2000 address. So 2, 3, 4, 5, 6, 7, 8. So without having any limitation on the number of characters it can provide, it will keep on reading the input from the user till he provides the new line character, right? So till then all the characters which whatever the user provides would be stored in your stack memory starting from this location 0x2000, that is the start of your array input OTP. Now the issue is, what the issue becomes is, you have your input OTP at this location 0x2000, and at 0x2004 you have your actual OTP, right? And then you have your name, say 0x2008. Okay, now since you are using getS function, it does not prevent the user from providing extra characters. So what basically happens is, the attacker can keep on providing extra characters like 2 2 2 2 2 2 2 2. Basically you can just sort of give extra characters, and what happens is all these extra characters apart from the first 3 characters which the user provides, right, only these 3 characters are stored as part of your input OTP, and all the remaining characters are sort of overflows into the adjacent memory regions, that is your actual OTP and also your name variable. So basically what happens is, I expect my user to provide just 3 characters, but if the user is malicious and if he provides extra characters, it sort of overflows. So here the term I use is overflows, right? You have this buffer, so we have this buffer or this array, this memory buffer present, and this memory buffer overflows. So it has the capacity to just have to fill in 3 characters, but you are providing more number of characters, and what happens, it overflows, and all those extra characters are populated in the adjacent memory regions, which are actually storing some credible data. And don't, sorry, did anyone raise your question? Is the screen not visible? Okay, sorry. Sorry, my bad. Sorry, my bad. Let me just have a quick re-explanation. So basically, what I meant is, so what I specified is, in this stack frame pertaining to the process function, this is the order in which we are storing the variables, okay, and provided at these addresses, right, 2000, 2004, and 2008. Now, if I use the getters function to read in my input OTP, and if I uh, give a long value, say triple two, some 2222, right? These first three digits alone would be stored as part of your input OTP. The remaining digits, right? Whatever above those three digits which were expected, all these are sort of stored in the adjacent memory locations. So basically, this is what you mean by overflow. So your input OTP acts as sort of a buffer, and the buffer capacity, your memory buffer capacity, is just 3 bytes or just 3 characters, right? But if you provide more than those 3 characters, it overflows, and while overflowing, it overflows and corrupts the adjacent memory regions, which namely the OTP array and the name array, which were once holding uh, proper credible data. Those data elements get corrupted because of this overflow issue, okay. And the main problem is, instead of using the fgetters, right, we are using this getters function, which does not place any restriction on the number of characters that the user can provide. So this is the main the problem with the code, which the attacker can misuse to sort of corrupt your OTP as well as the name array, right, and gain access to the reveal secret function. Okay, so is this logic clear? How I am able to corrupt my actual OTP and get access to the reveal secret function. So now, if I with this knowledge, if I provide anything, so for example, I can provide any value. So basically, I can provide any value such that it's a 7-digit number. My first 3 digits and the last 3 digits should be equal. Okay, and what happens is, right, and um, what happens is, say for example, if I provide this specific value 2341234, let me just be specific. So what happens is, these 3 digits 234 are stored in my input OTP, okay, and these 3 digits 234 are stored in my actual OTP. And any guesses why this extra one I have to specify in between? Some random digit, some arbitrary digit I should specify in between. Any guesses? Right. So that's basically your end of the null symbol at the end of your character array, right? So if you basically if you look at the code, it will be sort of, we'll have this code character OTP of 4 characters, character input OTP of 4. So my actual OTP value is stored in the first 3 digits, first three bytes only, of the first 3 digits, and the fourth byte is actually my termination, the null character, right? So I cannot, the null character is basically the new line, right? So I cannot provide that null character in my by my keyboard. The getters function will stop reading characters from the user if I press the new line option, the enter key. So instead of that, what I do is I change the fourth byte also to some random, to some arbitrary digit like 1 or 2, right? And I make sure the remaining digits that I pass is the same as the 3 digits, so that when I compare my input OTP with the actual OTP, it's sort of the condition check succeeds, and I am able to invoke my reveal secret function. Okay, so is this logic clear as to how what the vulnerability was, and why, and what we can do, uh, what we can achieve with this vulnerability? Is this clear? Any queries you have?
Can you change the get function to get function?
Sorry, it's not audible.
Sir, can you change
Yeah.
the get
Uh,
function to get function?
yes. So if I change the getTest to fgetTest, that's a possible mitigation where I can restrict the number of characters, right? So basically, I can do this. So gcc source1.c, and right. So basically, it so if you notice, basically it doesn't um, disturb or corrupt my actual OTP or even the username. It just reads in the first 3 characters, and all the other characters, whatever it reads from the user, is thrown away or discarded by the fgetters function. So that's the possible mitigation to this vulnerability. So anyone, uh, you have any doubts on the process layout that I explained, or how this program executes, the logic of the program, or what the vulnerability is, how we were able to invoke this reveal secret function by succeeding in this checking condition by passing a malicious input. So were you all able to understand?
Excuse me, sir.
Yeah,
Sir, if we give more than 7 characters
right.
in the for the OTP, will our username get affected?
Good question. Yes. So, uh, we another way to look at the your question is, why not just 7 characters? If I pass say 30 characters, what will happen? Okay. So here I just passing 7 characters. But let's say I pass 30 characters or something like. Okay. So for now we'll ignore this message. So basically we sort of so in the previous one where we just entered 7 characters, we got this congrats message, congrats Sai, and it exited well. Whereas when we pass this long digit, right, we get this congrats message. But if you notice, my username is also changed now. So all these extra characters, as you mentioned, uh, is the username specifically. It has been changed to this long value, to some garbage value. And also, in the later part of the course, we'll be having a deep look into what my actual process contents would look like, what the stack frame, what other information your stack frame has. So uh, apart from your local variables, your stack frame also has some extra information pertaining to your call chain. So for example, if you have your if if you have this main function which invokes the process function, and the process function invokes getters function, printf function, right? So all this forms a part of a call chain. So the list of functions which are being invoked in some specific order, and all these information is recorded in your stack frame. And apart from the local variables, right, extra information, some metadata is stored in your stack frame. And what happens is when you pass say 30 or 40 characters, right, those metadata also gets corrupted, and it opens up a lot of possibilities for exploitation. So we'll be looking into those in detail in the upcoming lectures. But for now, this sort of I want to introduce you to this local exploit where within this local variables itself, we can make use of an overflow exploit where we are using this get, where the attacker misuses the getters function, makes use of this vulnerability found in your program logic, where the developer has used the getters function to read the input OTP, which does not prevent the attacker from providing just 3 characters. Instead, the attacker can provide any number of characters, and that is misused by the attacker to corrupt the actual OTP, which is also being stored in the same stack frame, and succeed in uh, this condition check and invoke the reveal secret function, right? So this the developer who had coded this logic would have probably coded in the assumption that none of them should be able to pass this condition, because I'm reading from a random file, the actual OTP is randomized. So unless you do a brute force method or something, it's not possible for the possible for anyone to get the congrats message. But using this getters vulnerability, the attacker is able to bypass the condition check and get to this reveal secret function. Okay. So is this logic clear why the attacker was able to succeed, and the input that I should be providing so that the condition check succeeds? Any doubts in this specific example?
How do you came to know about the order of variable which will be stored in the stack?
Okay, good question. So for that, we will be using GDB. Okay. So in a later lecture, so basically this the order. Excuse me. So the um, the first variable, the local variables, like the order of the local variables would be, the first one would be at the lower base of your stack frame. So for example, if your stack frame is from location 1000 to 1100, then the first variable would be stored at 1000, the second variable at say some 1010 or something based on the size of that variable. So it will be stored in the increasing order within the stack frame. So that's actually a good question. So for example, if I change the ordering of my local variables, so say if I keep it in input OTP at the last, let's see what happens. Let me compile the program gcc source1.c and let me do it. So enter the username Sai. Let me give 123 1 2. So here, if you notice, uh, the input OTP 123, the first three bytes are read properly, but the extra digits whatever I am passing are not corrupting my actual OTP. Okay, the reason is, let me just show my screen. So the reason is, now once I change the order of my local variables in the function, the order in which they were declared, what happens is basically my input OTP is present over here, my name is over here, the OTP is the actual OTP. So let's have 0x2000, 0x2004, 0x2050, 0x2054, right? And this is the order in which your memory writes should occur. So when I'm using the getters function, input OTP, what it basically does is it starts populating my stack, populating the buffer, the input OTP array, starting from this location and goes upwards, as in it increases in a increasing order of the address range. So it starts from 2050 and it populates the values up till 2054 or beyond, right? So what happens is all the extra characters that I provide, it overflows beyond this 2054 address. So if you are storing any other data over here at 0x2060 or something, all these would be corrupted, but all the variables which are present below your input OTP at lower addresses, right? This the actual OTP and name, these are all not corrupted. So the order in which your local variables are declared also plays a crucial role in these buffer overflow exploits. So that's a good question actually, right? So two ways to mitigate the getters vulnerability, right? The straightforward way, you can use fgetters function. That's a straightforward way. That is one. The second one, you can change your way of input with the order of declaring the variables, but that's not recommended because if I'm still using getters, right? If I'm still using getters and I've just changed the order in which my local variables are declared, the that will prevent me from corrupting my actual OTP, and my reveal secret function would not be invoked. But there is the case that there is this metadata also, which we'll be seeing later, which is being present as part of your stack frame, or some other data might be present. And what happens is those might be corrupted, okay, uh, as part of your as part of this overflow. So instead of so the better solution or mitigation is to use this fgetters as you all have mentioned. Okay. Yes, Anjanatri. The class would be recorded, and I'll be uploading the videos on YouTube or some Google Drive folder. I'll be sharing the link by tomorrow. And yes, I will be posting relevant reading material for each week in Discord. So whatever I am discussing in class, in the lectures, right? Those would be sort of self-explanatory. But for those who are interested to dwell more into the topic, to get a bit of history and a context, and to practice more, I'd be sharing resources in the Discord channel pertaining to that week's lecture. Yes, I'll be sharing these slides also. Whatever slides I've written, this handwritten slides with doc, I'll be sharing these also. So, as everyone understood the logic of this exploit, so Raja Bharati has raised your hand. Do you have any specific query? Raja Bharati. Okay, cool. So, anyone else? Do you have any queries or anything? Okay, so how do we get to know about the vulnerability? Interesting. So, that, so getting to know about the vulnerability, we'll be seeing at a later lecture. How we will get to know about the vulnerability. There are many ways um, uh, we can get to know. So, for example, there is this. So one way is given any program binary, right? So here I had, for example, so here I had sort of shown the program logic, and we got to know that they are using this getters function, which is vulnerable. But in a real world scenario, you might not have access to the program logic. So what would happen in that case? How do we find a vulnerability is either we look at the actual binary, the instructions itself, and try to analyze the functions, go through those functions and see whether this getters or some vulnerable function is being read like that. But doing a manual inspection is sort of difficult, it's not practical. So there are tools, sort of fuzzing tools and all those stuff. And what they do is in our exploit also, right, the key aspect that we want to the key takeaway is the developer expected only 3 characters, but the attacker is not following that rule, but instead the attacker is providing more number of characters than what the developer was expecting. So that's the key takeaway. So basically he's trying to break your logic, break the program. So in fuzzing and all these vulnerability discovery tools, right, they perform some sort of analysis on the program execution, and they provide different inputs to the program and see whether it behaves erroneously or behaves in some weird fashion, or it results in some segmentation fault, or it abruptly stops or something. So basically what it means is, given some invalid input which the developer was not expecting, and the logic is not present in that code base, right, in that program, then your program might behave weirdly, and that might open up possibilities for the attacker to enter into your system and gain control. So those are all potential vulnerabilities that the attacker might try to focus on. So providing these inputs. So here 3 characters, it's mentioned. What will happen if I specify 7 characters? Let's try it out and check. So this should be the mentality of the attacker. Break the rules from the word go. So that's basically the way the attacker sort of tries to find these vulnerabilities. And there are tools we'll be having towards the end of the course, we will be having a look at a couple of tools to find these vulnerabilities. So in the first part of the course, in the majority of the course, we will be having direct access to the source logic, or we'll directly start from the point of vulnerability and understand what that vulnerability is and how it can be exploited. And in the later part of the course, we will see a couple of tools where we can where we'll demonstrate how do we in the first place get to know of that vulnerability. So we can take a real world exploit and see how some security engineer or someone was able to find that vulnerability in the first place. So Varun, is that question answered? Okay, cool. So anyone else, any questions, are able to understand exploit logic? So this concept uh, could be quite new, but we are actually scratching the tip of the iceberg, right? There's so much in this security field, and it's this course itself is sort of an introductory course, in my opinion, to the cyber security field, right? So do you have any other specific queries in this logic, in this function that you want to ask? Okay, so okay, introduce myself. Yeah, I introduced myself in the starting of the lecture, so I can delete it. Any doubts in this logic? If there are no specific queries, then we can wrap up this session. I'll be passing a feedback form on Discord. Those who attended, please do fill out that form. I won't be. It's an anonymous form, so your email IDs or those won't be tracked. So you can key in your honest feedback or suggestions for improvement, and based on that, we can change how the course has to be taught during the rest of the lectures, right? And also a quick announcement, tomorrow we won't be having a lecture class. So usually I'd mentioned on Fridays and Saturdays, but due to some unforeseen circumstance, tomorrow I won't be able to conduct a lecture. So the next class would be on next week Friday, and from that week onwards we'll be having two classes every week. Apologies for tomorrow's class cancellation. So if you have no other specific queries, we can end this session. Thank you.